Hello, we are discussing about GATE 2007 ECE paper. Look at the circuit shown. Given voltage across the capacitor Vc is 0 volts at t is equal to 0 seconds, and for t greater than 0 find the capacitor current Ic of t where t is in seconds. So Ic means current flowing through the capacitor. We know the relationship between capacitor voltage and capacitor current. Capacitor current can be written as C into dV by dt. V means Vc of t by dt. This is equation. That is relation which is giving the capacitor current flowing through the capacitor and voltage across the capacitor. So first we need to get the expression for the Vc of t, voltage across capacitor, then take the differentiation and substitute over here to get the Ic of t, which is the required answer. Now, voltage across the capacitor can be written as Vc, voltage across the capacitor, voltage across capacitor at any time t. At any point of time you can calculate voltage across capacitor, okay, by using this equation. Vc of t is equal to Vc at infinity plus Vc at 0 minus Vc at infinity into e power minus t by tau, where tau is the time constant. Vc of infinity is voltage across capacitor at t is equal to infinity, voltage across capacitor at t is equal to 0. Okay, Vc of 0 means Vc at t is equal to 0. Okay, it was given as Vc is equal to 0 volts at t is equal to 0 seconds. So the value of this one is 0. And Vc at infinity means voltage across capacitor at t is equal to infinity. At t is equal to infinity, we need to calculate Vc first. Remember that one, at t is equal to infinity, steady state is reached. Steady state is reached where the capacitor acts as open circuit. When capacitor is act as open circuit, then the circuit is going to be looking like this way. Capacitor is acting as open circuit. Now voltage across capacitor is same as voltage across this R2 value. By using voltage division rule, you can calculate, okay, Vc of t is equal to infinity is R2 divided by R1 plus R2 into input voltage Vi. Since R1 and R2 are same, so this you are going to get it as half of input voltage, that is 5 volts. So what we have seen is Vc of Vc at infinity is 5 volts, Vt at 0 is 0 volts, and tau value, tau is equal to R equivalent into C. We are going with only one capacitor, but strictly speaking it is R equivalent into C equivalent across the terminals of interest. Between these two terminals, what is equivalent capacitance, what is equivalent resistance? Since you have only one capacitor, that you can write it as directly C. And equivalent resistance, R equivalent can be written by finding R equivalent between these two terminals of interest. Consider the resistances. Equivalent resistance can be calculated by nullifying the independent sources. Nullifying the independent sources is if there is an independent voltage source, that will be shorted. If there is an independent current source, that will be gets open circuit. So nullify this one. That is, independent voltage source is now shorted. Because you are going to calculate Thevenin's resistance, that is equivalent resistance across these two terminals, by that time no other voltage sources or current sources should be present. Then it looks like this 20k and this 20k are in parallel. So R equivalent is equal to 20 parallel 20, that will be giving half. So 10 kilo ohms you will get. So tau is equal to 10k into C. 10k means 10 power plus 3, and C value is 4 microfarad, that is 4 into 10 power minus 6. tau is equal to 40 milliseconds. Tau we got it as 40 milliseconds. That means 40 into 10 power minus 3 seconds. Okay. Now we know each and every value in this equation. Get the value of Vc of t. So Vc of t can be written as Vc of t is equal to Vc at infinity is 5 volts plus 0 minus 5 into e power minus t by tau. Tau means 40 milliseconds. So this will be 5 minus 5 times of e power minus t by 40 into 10 power minus 3. So this you can write it as 5 if you take common, e power minus 1250 t you will get. This is Vc of t. Take differentiation, dVc of t by dt. Okay, dVc of t by dt is 1 by 4. This is only 25. Minus 25 t you will get. And next minus 25 t this will be. And differentiation, this is 5 differentiation is constant 0, and this is minus 5 into e power minus 25 t into minus 25. That means 125. It means this is minus 25 t. So this you are going to get it as minus 125. Minus 125 minus into minus, it will become plus 125 into e power minus 25 t. So substitute it in the equation 1. From equation 1 you can write it as Ic of t is equal to, C value is 4 into 10 power minus 6 into 125 into e power minus 25 t. So this is 125 into 4 means 500 into 10 power minus 6 into e power minus 25 t amperes. So this you can write it as 0.5 into 10 power plus 3. So 0.5 into 10 power plus 3, 10 power minus 6. That will become 10 power minus 3, which I am writing it as milliamperes. Okay, previously amperes, now I am writing it as milliamperes. So this is 0.5 into e power minus 25 t is the I of t expression, Ic of t. Ic of t is 0.5 e power minus 25 t. 0.5 e power minus 25 t is option is A. A is the right option.